Assalamualaikum and happy good day to everybody. I am Zulhan from Polytechnic Sarawak. On behalf of my team members, Dr. Ain, BT Ali, and Mazid Waddington, I would like to present a study of assessment of carbon footprint and thermal comfort in welding and concrete laboratory. So the term carbon footprint refers to the amount of carbon dioxide released into atmosphere as a result of its activities. Climate change and greenhouse gas emission are accelerated. With an increase in the use of fossil fuel throughout the Industrial Revolution, the amount of carbon dioxide in the atmosphere rises directly in proportion. So this research focuses on creating a sustainable environment that may be inhabited with comfort. Our period is known for its climate change and greenhouse gas emission. So this is because industrial expansion directly raises carbon dioxide level in the atmosphere. So we decide to gather data on carbon footprint, particularly in our institutions, Polytechnic Kuching Sarawak, such as concrete lab and welding workshop. This research will examine the link between carbon footprint and thermal imaging. With this study, tenants of Polytechnic Kuching Sarawak may become more mindful of their carbon footprint and thermal energy use. Study will collect data to ensure the environmental sustainability of an institution, especially Polytechnic Kuching Sarawak. We will compare the data to ASHRAE 55 standard and ICSITVE Guide A standard to provide the optimum solution for an institution sustainability. The purpose of this research is to inspect the carbon footprint in the building of Polytechnic Kuching Sarawak institution and to use the data collected in obtaining sustainable environment. So the objective of the research are determining the carbon footprint in concrete and welding lab by using a detector. Number two, relationship between carbon dioxide emission with heat, thermal, and to collect the correlation of the temperature, humidity, lux level, and air velocity of the concrete and welding lab. And last one, giving proper recommendation on way to overcome problem related to environmental sustainability according to ASHRAE 55 standard and ICSITVE Guide A. Next, we go to methodology section. So adaptive thermal comfort method are used in research, refer class 1.2.2 thermal comfort and a method definition of main thermal parameters. Environmental design 2007 parameters needed in this research are indoor air temperature, relative humidity, and air speed. These are devices used for data collection. The first one is lux meter, brightness measuring tools, and the second one is air detector, CO2, TVOC measuring tools. The zone typically occupied by people within a space is considered 1.8 meter above the floor and more than 1 meter from outside walls or window and 0.3 from internal wall. Point of data collection are around 4 to 20 for locations, depending on the area of the locations accessed. To be specific, the time accessed was approximately 50 minutes and more, based on the device that will be used. Variables that are going to be collected for data are minimum and maximum temperature for hot and cold, lux level, air velocity, carbon dioxide level, TVOC, temperature, and humidity. After all of the data collected, the average of each variable will be calculated. After that, average data of temperature will be compared to average data of air speed to see the relation between both of data collected. Hence, the total calculated data will then be compared to ASHRAE 55 standard of thermal comfort OSHA, and Jabatan Kerja Raya to give recommendation for sustainable environment. Next, we go to result and analysis. Concrete lab is where a student will do practical tasks such as mixing concrete, evaluating the quality and quantity of concrete, and fabricating precast concrete. Based on the table of concrete lab, data collected from 12 points, it has an average minimum and maximum of temperature of 28.9 degrees Celsius and 32.2 degrees Celsius respectively. It has a minimum cold temperature of 28.8 degrees Celsius and a maximum cold temperature of 33.8 degrees Celsius. The average lux intensity is 304.17 lux. The average velocity is 0.16 meter per second, whereas the carbon dioxide level is 519.33 ppm and TVOC is 0.089 milligram per meter cube with a temperature of 26.92 degrees Celsius as well as humidity level of 77.17%. Welding lab provides a hands-on learning environment where students may practice arch welding, mixed welding, and other welding techniques. Despite being situated in the same structure, this welding lab includes a number of distinct rooms. Based on the table of welding lab data collected from 20 points, it has an average minimum and maximum hot temperature of 29.7 degrees Celsius and 35.4 degrees Celsius respectively, a minimum cold temperature of 32.6 degrees Celsius and a maximum cold temperature of 37.6 degrees Celsius. The average lux intensity is 84.45 lux. Average velocity is 0.02 meter per second. The carbon dioxide level of 481.3 ppm and TVOC of 0.09005 milligram per meter cube with a temperature of 28.15 degrees Celsius as well as humidity level of 75.2%. Then we go to discussion. According to OSHA regulation, carbon dioxide level between 1,000 and 2,500 parts per million may produce general drowsiness. Methylation rate should be maintained below 1,000 ppm of carbon dioxide in order to ensure acceptable indoor quality condition for the vast majority of individuals. In terms of the concrete lab and welding lab, it complies with the OSHA requirement for levels that are regarded acceptable. According to X-ray 55-2010, the speed for a space is stated as the comfort zone for an environment that fit this standard and has a speed of less than 0.2 meter per second. This information is available on Figure 1, American Society of Heating, Refrigerating, and Air Conditioning Engineers, X-ray Standard 55, 2010-2011. Both the concrete lab and welding lab have a velocity of less than 0.2 meter per second, having previously been 0.16 meter per second and 0.2 meter per second, respectively. So the average air speed estimated for both accessible site meets the X-ray 55 guideline, indicating that the facility are appropriate for occupation. Based on H3 55 parameters as plotted in this cross-section diagram, the temperature of the concrete lab is 26.92 degrees Celsius with air velocity of 0.16 meter per second, and for welding lab, the average temperature is 28.15 degrees Celsius and air velocity is 0.02 meter per second. Both of the buildings do not meet the requirement standard of H355 thermal comfort as they are considered too hot. The yellow colored line indicates the thermal comfort for concrete lab, while the blue colored line indicates the thermal comfort of welding lab. As a conclusion, this study clearly showed that the heat thermal energy, air velocity, and humidity does contribute to carbon footprint. The result revealed that the average carbon dioxide level of the concrete lab 0.089 milligram per meter cube is 519.33 ppm, and welding lab is 0.09 milligram per meter cube is 481 ppm. Refer to air quality index, the acceptable ppm value is below than 500 to 1000 ppm. Both accessible sites had calculated average air speed that matched ASHRAE 55, suggesting that the places are suitable for occupancy. Air velocity in both labs are less than 0.2 meter per second. Therefore, overcoming this issue is crucial in order to build a sustainable environment for future generations. Thank you.